All right, wonderful people. Remember, this is what we had on the screen. And they said the complex number z satisfies this equation, where z bar denotes the complex conjugate of z. So we are told that z bar denotes a complex conjugate of z. And then they say to us, solve the equation giving your answer in the form x plus I. We should solve giving our answer in this form x plus yi, where x and y are real numbers. So x is an element of a real number and y is also an element of a real number. So this is exactly what we have, and this is exactly what we would like to solve. So I'm going to say, okay, let me try to find the solution to this problem. Now I'm going to copy down 4z minus 3z bar, that is 1 minus 18i into 2 minus I. This is exactly what I have. Now the question will be, how do we solve this? If z bar denotes the complex conjugate of z, now how do I know the value of z and the value of z bar? That should be the question. Okay, so I think what I can do in a problem like this, the first thing that I can do is the following. I can say, okay, if I should find my answer in the form of x plus y I, where I denotes a complex number, the real root and the imaginary root. By looking at this, I can see that this is highly problematic. Why? Because I do not even have the values of x and y. So if I don't have the values of x and y, the question would be, how will I solve this? Can you see that the problem that is provided, we don't have this x and y? So I can say let z be equals to x plus yi, so that the complex conjugate of z, which is z bar, can be x minus yi. I can say this. Why? They want the answer in the form x plus yi, and both x and y should be elements of a real number. And if they want this in this form, that should give me an idea that, okay, let me allow z to be x plus yi, where the complex conjugate of z, which is z bar, will be x minus yi. We all understand that. We all know this. And then from there, that simply means in this equation where I see z, I'll write that, and where I see z bar, I will substitute with this. This is one most important thing. So I'm going to say for open bracket, I see z, I write x plus yi minus 3. I see z bar, and I'm writing x minus yi, and this is equal 1 minus 18i, 2 minus I. Somebody already understands exactly what is to transpire in this. And then the simplicity of the problem is just to multiply out so that we understand exactly what needs to happen there. So we can have 4x plus 4yi. This would be minus 3x plus 3yi. And this must be equals to 1 minus 18i divided by 2 minus I. So this is the complex of the problem that we have, trying to simplify this and trying to group the like terms. As you can see that this and this are the same. So I can say 4x minus 3x will give me x, very important. 4yi plus 3yi, that should give me 7yi, because they are like terms. And this will be 1 minus 18i divided by 2 minus I. Very important that we understand that. And then now the problem can be simplified, because we can take the complex conjugate of the denominator, or we can rationalize the denominator by multiplying by 2 plus I, 2 plus I. Very important. So this will multiply with this, and this will multiply with that. So I can have x plus 7yi, that is equals to this 2 plus I minus 18 times 2, that would be 18 plus 18. 8 plus 8 is 16, that will be 36. So I can have minus 36i minus 18i squared. Divide this times this is 4. This will be plus 2i minus 2i minus I squared. And we are very much fine. We can now try to work with this and see how far we can simplify. X plus 7yi, that would be, I have my 2i minus 36, that will be minus 35i minus 18 into minus 1, because I squared equals minus 1, divided by 4 minus into minus 1. Very important that we see that. Highly and highly important. Now I'm going to take this to this side. Let me just come here. X plus 7yi equals. Now here you will have 2 minus 35i plus 18 divided by 4 plus 1. And then when we are there, let me just try to find a marker very quickly. Okay, so we have x plus 7yi, that is equals to 2 plus 18, that will be 20, minus 35i divided by 5. And 5 can divide in this. X plus 7yi equals 20 over 5 minus 35 over 5i. X plus 7yi equals, so this would be 5, 10, 15, 20. So I will have a value of 4. So I'll say 4 minus 5, 10, 15, 20, 25, 30, 35, 7i. So when we are in this, we can say that x equals 4 or 7 equals, y. But can you see that we have 7y here? We can say 7y equals negative 7. And dividing there, you'll find your y as negative 1. This is very important that we understand that. So your x will be 4 and your y will be negative 1. And when that is done, you're more than happy, because this is exactly what we wanted to solve. And then we are very much fine.